when y'all did 8.1, okay, it was over similar triangles, correct? Did you notice how similar the concept was to our congruent triangles, where we were labeling the 1, 2, 3 and the 1, 2, 3 and all that, right? Okay. So basically all you're doing is you're taking your original triangle and then you are shrinking or enlarging it to get the second triangle. Sometimes your triangles will be stacked on top of each other. Sometimes they'll be twisted a little bit, whatever. So today we're going to look at the mid-segments and we're going to look at some proportionality, okay? So the mid-segment of a triangle. The mid-segment of a triangle is a segment that, let's see, connects the midpoints of two sides of a triangle. Okay, it connects the midpoint. So notice that point D is a midpoint. How do I know it's a midpoint? Because there are matching tick marks on either side. Point E is a midpoint because it has matching tick marks on either side. Therefore, DE is a midsegment. Okay, the theorem states that if a segment connects the midpoints of two sides of a triangle, then that segment is parallel to the third side. So it connects two sides and it's parallel to the third side. And it is half as long. So this is what it looks like. So DE is parallel to AC and DE is half of AC. Or think about it. If DE, the segment right here, is half of this side, then doesn't that mean that this side right here is twice as long, the mid-segment? Okay, does everybody agree with that? Yes. All right, so what we need to do on our picture is we need to mark that DE is parallel to AC. So keep in mind, now that we have parallel lines, we're going to have the transversals, so you're going to have corresponding angles and things like that. Because now this angle right here is going to correspond with this angle, therefore it's going to be congruent. Same thing with this one over here. E is going to correspond with C, therefore they're going to be congruent because these are parallel. Okay, make sense? Yes. All right. So now let's set up and solve some proportions. So since DE is a midsegment, well, since it's a midsegment, then I know it's going to be parallel. And since it's a midsegment, I know that DE is half of BC. So plug in what it is. Well, what is DE? It's X. Half of BC, half of 28. So X is 1/2 of 28, therefore X is 14. So that means that is 14. Same concept. If DE is half of BC and 2 DEs equal 1 BC, then 2 times 15 equals BC, so BC is 30. Okay. Now, over here in this picture, since they are telling you up here in the directions that DE is a midsegment, so we know it's parallel because it's a midsegment. Since it's a midsegment, that means this is a midpoint, therefore this is equal to this. So with that, since DE is a midsegment, it splits the sides equally, so that side is 9. So this side is 9 and this side is 9, so what's the whole thing? The whole thing would be 18. It's pretty basic, pretty easy. All right, so now let's look at what happens when it's not just plain numbers. What if it's an algebraic expression? So still the same rule applies. DE is still half of BC, right? So since DE is 3x plus 8, it's going to be half of 2x plus 24. So that's going to give me 3x plus 8, which is x plus 12. Because half of 2 is x, and half of 24 is 12. If I subtract x, I get 2x plus 8 equals 12. Subtract 8, I get 2x equals 4. So therefore, x is 2. But they're not asking for x, so I have to plug it in. So I know that DE is going to be 3 times 2 plus 8. So that would be 14. Now, keep this in mind when you're setting this up. Since DE is half of AB, but if you notice, AB is 7x minus 1. Well, I don't want decimals. When I take half of 7, I'm going to get 3.5. When I take half of 1, I'm going to get 0.5. I don't want decimals. So remember, if it's half of something and that something is not even numbers, then maybe I should do the other one where it's 2 times DE is equal to. So if I did 2 times DE equals 1 AB. Just use the other rule. So now I've got 8x minus 6 equals 7x minus 1. Subtract 7x, then add 6. So now I get that x is 5. Well, if I plug it in, 4 times 5 minus 3 is 17. So DE is 17. All right, so I have a little paragraph down here. So they want me to find the perimeter of DEF. Okay, well, DEF is this tiny triangle that's in here, correct? So think about this. Since triangle DEF is made up of midsegments, we call it a midsegment triangle. Midsegments are half the length of the side they're parallel to. So if all of these sides are half, then wouldn't the perimeter be half also? So, yes. So think about it. You have this picture up here. This side right here is 45, so this side is going to be 22.5. This side is 13, so this is half, so this is 6.5. This side over here is 38, so this half is 19. Well, if you add those three numbers up, you get 48. Well, if I add up the perimeter of ABC, it's going to be 96 because 13 plus 38 plus 45 equals 96. So that means that the perimeter is similar to the larger perimeter. How similar is it? It's half, because all the sides are half. Also keep in mind that these 4 triangles right here, they're all congruent to each other. They're all the same triangle, flipped, twisted, and turned. And each one of them is going to be similar to the larger triangle ABC. All right, so now we're going to talk about the proportionality theorem. So, parallel lines and transversals, still here, okay? So, if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. I know that sounds crazy. In other words, if you draw a line through a triangle so that it's parallel, kind of like the midsegment, okay? But this doesn't just apply to the midsegment. This applies to everything. Basically, what it's doing is it's going to split this side proportionally with this side. A midsegment splits them equal. This just splits them proportionally. So think about this concept. If UT is parallel to QS, such as it's marked, then RT, I'm going to call this RT as A, over QT, I'm going to call that B, is equal to RU over SU. In other words, A over B is equal to C over D. And if you look at it, if you were to extend the side, it's already set up as a proportion, A over B, C over D. So if you extend that parallel side to outside the triangle, then it already sets the proportion up for you. And the converse is also true. So just flip those two, just like we did in conditional statements. If RT over QT is equal to RU over SU, then UT is parallel to QS. All right, so here we go. So we're going to find the length x. So this is my x right here. So if I follow that rule where the sides are already set up for me, so if you were to extend this side of the triangle, you're going to have 5 over 10, x over 6. So, okay, I don't know what happened there. So 5 over 10, x over 6, so cross multiply. 10 times x is 10x, 5 times 6 is 30, so x is 3. Well, if x is 3, well, then AB is also 3 because AB is x. Same thing over here. This is my x because this is the piece I'm looking for. So if you extend that side so that it sets it up for you, all my proportions over here are all crazy. 2 over 9, x over 7. 9x equals 14. Divide by 9, x is 1.6. Well, if x is 1.6, then AB is 1.6. Same thing over here. But I want y'all to look at this one for a second. If I extend my side, x over 7 is going to be this side, correct? But is this side going to be 27 over 6? No, it's got to be 21 because it's pieces over pieces, not pieces over whole sides. 27 is the whole side. You can't compare a whole side to a piece of a side if you're not doing the same thing on both sides of your triangle. Okay? So when we set it up, you're going to get x over 7, 21 over 6. Cross multiply and divide. Then that gives you that piece that's missing is 24.5. Okay. All right, so let's do this one here. See how it's already set up again? Like I said, if you extend that piece, it's already set up for you. So you get 30 over x plus 7 and 25 over 15. So when you cross multiply, you're going to get 25 times x plus 7 and 30 times 15. So then do your distribution. So 25x plus 175 equals 450. 25x equals 275. X is 11. Well, if x is 11, I got to plug it in. So x plus 7 is really 11 plus 7, which is 18. So AB is 18. Now look at number 13. Look at the proportion and look at the triangle. Do you agree or disagree with the way it is set up?
Which one?
On number 13. I have, and if you think about it as pieces, I've got 2 over 5 x over 10. Do you agree? Okay, if you're answering no, then you should be proud of yourself. No, 5 is only part of the whole side of that big triangle. Since you're comparing corresponding sides, you need to use 7 to represent the whole side. So this, if I'm using 2, then I've got to use this whole side because I'm using x and 10. Since x represents the base of the small triangle and 10 is the base of the large triangle, 2 is the left-hand side, so I need to use the left-hand side of the big triangle as well. Does that make sense? 2 is the little side, correct? Well, is 5 the whole piece of the big side? 5 is only representing part of the big side, isn't it? Then you've got to find the big side. Well, what's 2 plus 5? So you have to use 7 because 7 is what represents the whole side of the big triangle. 5 is only part of the big triangle. So basically what it boils down to is little, little, big, big. Okay, you can compare 4 little pieces, or you can compare 2 little and 2 big, but you can't have 3 of one thing and 1 of another. So see how this would be a piece of the big side, a piece of the big side, the whole side of the little, and the whole side of the big. It doesn't work. Proportions are proportional. That means they have corresponding pieces have to go together. That's why whenever you're doing units, you can't mix inches with feet unless you have 2 parts that are inches and 2 parts that are feet. Then you can mix, okay? But you can't have 3 pieces that are in inches and 1 part that's in feet. It has to be corresponding, and it has to be like terms go with like terms, okay? So let me show you what that looks like. I don't know what that means.